Okay, this is 3.3 of Algebra. So, we're going to look at multiplication in inequalities. So, this says that I can multiply both sides by the same number. You don't need to write down the property. Multiplication and division is what this section's about. So, if I look at this equation, I have x over 3 is less than negative 2. I need to get x alone to be able to graph it. So I need to multiply both sides by 3, because then these 3's cancel off and I'm just left with x. Negative 2 times 3 is negative 6. And then there's my graphing. Let's try our got it problem. I've got c over 8 is greater than 1/4. So I need to get c alone. Right now there's division happening, so to get rid of it, I need to multiply by 8 on both sides. 8's cancel out, so I'm just left with c, and I get c is greater than 2. So I'm going to have an open circle. So on my number line, I'm going to stick a 2, stick my 1 and my 3, with an open circle at 2. I'll plug in 1. So if I plug in 1 for c, I get 1 is greater than 2. That is false. So I don't go towards the 1, I go towards the 3. I go the other direction. And again, if I'm not sure if that's right, I can plug in 3 and I'd get 3 is greater than 2, which is true. And so it makes sense that it's crossing, it goes over 3. Okay, multiplying by a negative number. Here's the deal. So when we're solving inequalities, it's exactly the same as if I were solving an equation with an equal sign, except when I multiply by a negative number. When I multiply by a negative number, I flip my sign. So in this case, I have negative 3/4 w is greater than or equal to 3. To get rid of that fraction in front, remember I multiply by the reciprocal. So I'll multiply both sides by negative 4 over 3. Negative 4 over 3. So I get negative 4 over 3 times negative 3/4 w. And I need to flip that sign. 3 over 1 times negative 4 over 3. So over here my 4's cancel, my 3's cancel, and 2 negatives make a positive. So I'm just left with w over here, and my sign has now switched. And I multiply straight across over here, so I get negative 3 times 4 is 12. 1 times 3 is just 3. So this is w is less than or equal to negative 4. And you can see my graph over here. So, and if you weren't sure if it was true, let's plug in like negative 6. If I plug in negative 6, I get negative 6 is less than or equal to negative 4, which is true. But how about we plug it back up into that original one? I had negative 3/4 w is greater than or equal to 3, so that you can see that these in fact are the same things. So if I plug in negative 6, I get negative 3/4 times negative 6 is greater than or equal to 3. Negative 6 times negative 3/4 gives me a positive 4.5, which is greater than or equal to 3. So it is still true. Okay, so let's try ours here. Got negative n over 3 is less than negative 1. So there's division happening over here. I need to get n alone. So to get rid of that negative 3, I need to multiply by negative 3 on both sides. When I do, these cancel off and these become positive. I'm just left with n, and I need to flip that inequality symbol. It still doesn't have the line underneath it, right? It's still going to be an open circle, but I change what direction it's facing. Negative 1 times negative 3 is a positive 3. So then on my number line, 3, 2, and 4. Again, I have an open circle because it doesn't have the line underneath it. It's not or equal to. And then I can plug in number to try. So if I plug in 4, I get 4 is greater than 3, which is true. So I go towards 4. Like that. Okay, I can also divide both sides by the same number. Again, you don't need to write this property down. Okay, here's a story problem. Let's just do our got it problem down here. A student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend at most $50 for this project. What are the possible numbers of cases the club can buy? Okay, so each case costs $10.68. So if I buy 1, that's $10.68. If I buy 2, to figure out the price, I do 2 times $10.68. So I do the cost times the quantity. So I'll do 10.68, we'll call it V, and I have $50. $50 is the most that we can spend. That is the biggest that it can be. So it needs to be facing this way. And it's okay if I spend exactly 50. So I have the or equal to symbol there. So to get V alone, and I have multiplication right now, so I need to divide by 10.68. Divide by 10.68. And I got that V is less than or equal to 4.7 approximately. And in this case, since we're working with whole numbers, I can't buy 4.7 cases, right? But I know that V is going to be smaller than that, right? 4.7 is as big as it can be. So my possible answers then, since we need to work with whole numbers, is going to be 4 cases, 3 cases, 2 cases, or 1 case. So 4, 3, 2, or 1. I guess you could buy 0, but that doesn't quite make sense. Okay, if I divide by a negative number, I need to flip the sign as well. So if you look over here, when I divide by -9, my symbol, oh whoops, we already switched it. That's the way it started. My symbol switches when I divide by -9. So let's try our own problem. We've got -5x is greater than -10. Oh, it's got bad. Let's rewrite that. Okay, I need to get x alone, so I need to get rid of that -5. It's multiplication right now, so to get rid of it, I need to divide by -5 on both sides. And then I need to flip my sign, so I get x is less than 2. So to graph it, I'll put 2, 1, 3. This is an open circle. If I plug in 1, I get 1 is less than 2, which is correct. So I go this direction. That is true. I go this way. And there's your homework.